air. The ice and rain protection system on the ERJ-145 permits the aircraft to be operated in icing conditions and heavy rain. Ice protection is provided by heating critical areas of the aircraft with hot bleed air supplied by the pneumatic system, while other areas are heated by electrical power. The hot bleed air heated areas of the ERJ-145 are the wing and horizontal stabilizer leading edges and the engine air inlets. The wing and stabilizer ice detection system is primarily automatic and operates after sensing icing conditions. It then activates the hot air protection system and configures the integrated bleed pneumatic system. The ice detection system also sends an automatic signal to the stall protection system in order to reduce the angle of attack set values. This compensates for differences in allowable angle of attack during icing conditions. The electrical heating systems are also activated automatically. They consist of the windshield heaters, pitot-static heaters, and drain mast heaters. These heaters are normally selected to operate regardless of icing conditions. 2 independent wiper systems are provided to remove rain from the windshields. All of the ice protection systems send their signals and advisories to the ICAS. Anti-icing. The engine air inlet anti-icing buttons turn off or permit the automatic activation of the associated engine anti-icing system. If the engine air inlet anti-icing valve is open, an open inscription will show in the associated button. The wing anti-icing button will turn off or select the automatic mode of the wing anti-icing system. An open inscription displays in the button if both wing anti-icing valves are open when commanded open, or at least one valve is open with the system not commanded open. The horizontal stabilizer anti-icing button will allow the automatic activation of the anti-icing system. An open inscription will illuminate in the button to indicate the horizontal stabilizer anti-icing valve is open. The left, center, and right sensor heating buttons control the sensors as indicated on the panel. Pressing these buttons will cause the sensor heating to operate in the normal logic. Releasing these buttons will deactivate the sensor heating. The ice detection test knob permits all the anti-icing systems to operate briefly for testing purposes. Pressing this knob will cause all ice system indications to illuminate on the ICAS. With the ice detection override knob in the engine position, the engine air inlet heat is manually selected on. If the ice detection override knob is in the auto position, automatic operation of the anti-icing system operates. With the ice detection override knob in the all position, all areas of the ice detection are manually selected on while in flight. Note, the all position will only heat the engine inlets when on the ground. The windshield heating button will activate and deactivate the windshield heating system. A striped bar will illuminate in the button if the system is deactivated.
The sensor heating system provides automatic operation of pitot tubes 1 and 2, pitot static tube 3, the pressurization system and the air data system static ports, total air temperature sensors 1 and 2, and angle of attack vanes 1 and 2 heating elements. Pressing the associated sensor button provides automatic logic for the selected sensor heating system. Releasing the button turns the associated sensor heating system off. A striped bar illuminates inside the button whenever it's released.
Caution messages regarding the heaters will be presented on the ICAS. Buttons.
The windshields are electrically heated to prevent ice and fog formation. The windshield heating system may be selected to on during all phases of flight, but must be on prior to beginning the descent phase to prevent fogging due to higher thermal inertial to heat the inner windshield layer.
Left and right windshield heating is provided by two buttons located on the overhead panel. Separate power supplies are provided for each side of the windshield for redundancy.
The windshield heating system continuously monitors windshield temperature when the windshield heating push button is selected on. The system has two modes of operation: defog heat and anti-ice heat. In the defog mode, power is supplied when the temperature drops below 26 degrees centigrade and maintains this temperature. In the anti-ice mode, if the ice detectors sense ice formation, power input increases to maintain the temperature at 43 degrees centigrade. If the windshield temperature exceeds 65 degrees centigrade, an overheat condition will exist and a caution message will be displayed on the ICAS. The failed windshield heater should be turned off at this time.
The bleed air anti-ice system is supplied with hot air from the engines. Note, the APU bleed air is not hot enough to be used for anti-icing. Bleed air for engine anti-ice is provided by the high stage of the respective engine. Bleed air for wing anti-ice is provided through a valve on the respective side of the pneumatic system. In the event of failure of one engine bleed, the air for wing anti-ice can be provided from a single engine, as long as the cross-bleed valve is open. The aircraft is equipped with an automatic anti-ice system. This system detects ice through vibrating sensors that are located on the fuselage. With the automatic mode selected, when the sensors stop vibrating, it is assumed they are covered in ice. This situation will cause the anti-ice systems to automatically activate. When the detectors resume their normal vibration, the automatic anti-ice shuts off. This frame shows the controls for wing and engine anti-ice. The normal position of the override knob is the auto position. With the wing and engine buttons in their normal position and auto selected with the override knob, the wing and engine anti-ice will automatically activate in flight. An open light appears in each button when the respective valve is open. The anti-ice system is turned on automatically if any ice detector detects ice and may be turned on manually by using the override knob. Icing conditions exist anytime the temperature is at 10 degrees C or below and there is visible moisture present. Ice may be visible in the corners of the windshield during flight. Ice protection is provided to the leading edge of the wing and horizontal stabilizer, as well as the engine air inlet lips. The pneumatic system provides hot engine bleed air through perforated tubes called piccolo tubes. These tubes are routed along the surface of the area that needs to be heated. The perforations allow hot air to flow out of the tubes and heat the surface. Slots are included to allow the hot air to escape from the piccolo tubes after heating the surface. Each system incorporates an anti-icing valve that regulates pressure of the hot bleed air. Pressure switches are installed that monitor and indicate low and high air pressure abnormal conditions. Note, a low bleed air pressure condition may not provide enough warm air to prevent ice accumulation, while excessive bleed air pressure could cause structural damage. The horizontal stabilizer and the left wing is supplied by the left side of the pneumatic system, while the right wing is supplied by the right side. Engine anti-ice is provided by heating the engine air inlet with hot air delivered directly from a location upstream of each high-stage valve. The temperature of this air is not altered or controlled. Each engine has its own independent protection system, independent of the pneumatic system. Engine anti-ice may be operated on the ground because of the constant airflow surrounding the engine while it is running. Buttons on the overhead panel may be used to deactivate the system if necessary. In flight, the FADEC incorporates automatic logic to allow the engines to deliver maximum thrust to compensate for the loss of power due to the high bleed air consumption while the anti-icing systems are operating.
The ICAS caution message, "No ice anti-ice on" displays if the thermal anti-icing system detects any anti-icing valve opened, and neither ice detector senses icing conditions while the aircraft is in flight.
The pilot's vision. The left and right windshields are equipped with a 2-speed windshield wiper system. Each windshield wiper has its own independent power supply and a 4-position knob on the overhead panel. The off position will park the wipers out of sight of the pilot's vision. If the wiper knob is selected to the timer position, it will provide intermittent operation with 2 strokes of the wiper every 8 seconds. The low position will power the wiper to operate at approximately 80 strokes per minute. The high position will power the wiper to operate at approximately 140 strokes per minute.